Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to divide and multiply rational expressions. Alright, before we get started, we're going to take a look at some formulas that will guide our problem solving process, okay? So let's take a look at the following formulas. The first one is basically a property of equality, okay? Let's say you're multiplying two fractions, a over b times c over d, where c and d are not 0, okay? Well, whenever you're multiplying, all you simply do is you multiply horizontally. Numerator times numerator, ac, divided by denominator times denominator, bd. Okay? One thing you want to remember is that whenever you are multiplying or dividing fractions, you do not need the LCD. Finding the lowest common divisor denominator is only applicable to finding the sum and difference of fractions or rationals. Okay. Another formula you want to remember has to do with the division of polynomials, rational expressions, and also fractions. If you have a over b and you want to divide it by, let's say, c over d. Now what you do first is you drop, change, flip. Okay, you drop the first fraction, a over b, you change the division into a multiplication, and then you flip the second fraction, d over c. Okay, so what you'll notice is that we have changed the division problem into an equivalent multiplication problem. Okay, and then now we can apply the formula that we established in number 1, which is going to be AD over BC. Okay, so you just have to remember the process, which is drop, change, flip. Drop, change, flip. Okay? Alright, now the last formula we're going to be using just has to do with division of identical factors. What is A divided by A? A divided by A, all you simply do is, if you have identical or common factors in the numerator and the denominator, you can divide them out. Okay, so A goes into A once, and A goes into A once. And then you have 1 over 1, which is just, wrong color. You have 1 over 1, which is just 1. Okay, so bottom line, whenever you divide identical factors or common factors in the numerator and denominator, you end up with 1 as the result of that division process. Okay, this is not 0, it's equal to 1. All right, let's take a look at the first example. Let's say we're to multiply the rational expression. For number 1, let's say we have 6x squared divided by 35x multiplied by 10x divided by 9x to the third. These are rational expressions because they have a variable component in the denominator. Okay. All right. So to do this, the steps that we're going to follow are as follows. There are different ways you can multiply rationals, but this is the step I'm going to be implementing in this problem and in the next one. So first thing I'm going to do is we're going to combine. Okay, we're going to combine the fractions into 1 using the product property. And then after combining, writing the numerator and the denominator as a combined product, we're going to proceed to decompose. Okay, we're going to decompose composite parts of the numerator and denominator factors. After decomposing, the goal is to identify reducible factors. So step 3, as you would expect, is we're going to reduce. Okay, reduce or divide out common factors. And then lastly, we'll just simply multiply, and that will yield our final result. Okay? Alright, now let's go ahead and execute step 1. Let's combine these. Since we're multiplying two fractions, we're going to have numerator times numerator. So we can write this as 6x squared times 10x this entire thing divided by 35x times 9x to the third. Okay? So we're done executing step 1. Now what we're going to do is we're going to proceed to decompose. Alright? So let's decompose composite terms. Let's start with 6. So what is the prime factor decomposition of 6? You remember what your prime numbers are, right? So let's review that real quick. So prime numbers are numbers that are divisible by themselves and 1 only. Okay? So your prime numbers are 2, 3, 4 is not a prime because 2 goes into 4. 5 is prime. 6 is not a prime because 2 and 3 go into 6. 7 is prime. 8 is not because 2, 3, 4 go into 8. 9 is not prime because 3 goes into 9. 10 is not prime because 2 and 5 go into 10. 11. And the list goes on for eternity. Okay, so whenever you're decomposing your composites, you can only use prime factors. Okay, so let's decompose 6. If we decompose 6, we're going to have 2 goes into 6 3 times. Okay, so this 6x squared component is going to be 2 times 3. And then since it's x squared, it just means that we're multiplying x by itself twice. Okay, using our properties of exponents there. Now let's take a look at 10. 10 is composite. If we decompose 10, what do we have? As prime factors, we know 2 goes into 10 since it's even. 2 times 5. So that's 10. So we have, instead of 10, we're going to put 2 times 5 times x, since we just have one x. Okay. Now let's shift gears and take a look at the denominator. We have 35. That's a composite. Let's decompose it. 5 goes into 35 7 times. So 35x can be written as 5 times 7 times x. Next composite is 9. What prime number goes into 9? 3 goes into 9 3 times. So 9 is going to be 3 times 3. X is being raised to the third power, which means that we'll multiply x by itself 3 times. Okay? So let's go ahead and carry out step number 3. Reduction involves dividing identical factors in the numerator and denominator. Okay? Notice the 5's are identical, so we can divide that out. So 5 goes here 1, 5 goes there 1. What else? 7, there's no 7 in the numerator. How about the x's? Well, we have a lot of x's in the top and bottom, so let's go ahead and divide that. So x goes here once, x goes here once, and then x goes here once, x goes here once. Is that it? Nope, we have identical x's here. X goes here once, and x divides here 1. And that's that for the x's. How about the 3's? Yeah, we could divide that out. 3 goes into 3 once, and 3 goes into 3 once. That's taken out. And it looks like we have completely reduced this rational expression. Alright, so to finish it off, all we'll simply do is execute step number 4, which is to multiply. Okay, so we have 2 times 2. If we multiply 2 times all these ones right here, you get 4. And then in the denominator, we have 7 times 3 times x. 7 times 3, let me underline when I'm multiplying. So I multiply 2 and 2 to get 4. And then we're multiplying 7 times 3 times x. So 7 times 3 is 21 times x is x. So the final answer will be 21x. Okay? So that's how you multiply rational expressions. Alright, now let's take a look at another example. What if we were to divide? Okay, so for problem 2, we are to divide the following rational expressions. So what if we have, let's see, 6x divided by 15y squared this fraction divided by another rational, namely 12x y to the third divided by 5xy. Okay, now the steps that we took a look at earlier, the steps, these ones are for multiplying, okay? But when you're dividing, there is a step that comes before combining, decomposing, and reducing. So let's go ahead and take a look at the step for dividing. It's just one additional step, okay? So these are the steps to divide. To divide, first of all, you are going to DCF the problem. What does that mean? Drop, change, flip. Okay, you drop, change, flip, and then you just execute the steps in the multiplication process. Okay, so 2 is 1 for the other one. We combine. We're then going to reduce. No, before reduce, we decompose. So combine, decompose. So we can see the identical factors. That will make it easy for us to carry out step 4, which is to reduce or divide out common factors. And then step number 5, you then multiply across to get your final answer. Okay, so let's do it. So we're going to drop, change, flip, okay? Let me show you what that looks like. So drop involves just bringing down the dividend rational expression. So you just drop that down. So that remains unchanged. 6x over 15y squared. And then you're going to change your division into a multiplication operation. So that's the change. You change that, instead of divide, is now going to be multiply. And then the last one, you are going to reciprocate or flip. Okay, so this one gets flipped. What does it mean to flip? The numerator goes into the denominator position, and the denominator goes into the numerator position. So this becomes 5xy divided by 12xy cubed. Okay? Alright, so that's how you drop, change, flip. Now that we've dropped, change, flipped, we are now in the same position as we were in question number 1 at the start. We're now multiplying two rational terms. So to do that, we're going to go ahead and combine them. So if we combine them, we're going to have 6x times 5xy. That's the numerator. And then in the denominator position, we have, what do we have? We have 15y squared multiplied by 12xy to the third. Okay. Now let's go ahead and carry out the next step, which is the decomposition of our composites. 6 is definitely a composite. 2 goes there 3 times. So in place of 6x, we're going to have 2 times 3 times x. 5 is prime, so we just have 5 times x times y. And then we're going to go ahead and divide the entire numerator by the decomposed form of the denominator. Okay, so 15 is composites. 3 goes into 15 5 times. So you can write 15y squared as 3 times 5 times y times y. 12 is composite also. Let's decompose that. 2 goes into 12 6 times. 6 is composite, so we have to decompose that. 2 goes into 6 3 times. So the prime factor decomposition of 12 is 2 times 2 times 3. And then we have just one x, since x is to the first power. And then we have 3 y's multiplied by each other, since we have y to the third power. Okay. Alright, so that's the decomposed form of the problem, step number 3. Now what are we going to do next? Next step is to reduce. We're going to divide out identical factors between the numerator and denominator. Okay? So let's start with 3. 3 goes here 1, 3 goes here 1. And it looks like that's that for 3. Now how about 5? 5 goes here 1, 5 goes here 1. No more 5s. Now let's take a look at the x's. No, let's do y's first. So we have this y goes here 1, y goes here 1. And that's basically it. And then last but not the least, we have 2 and we also have x's because we're done with the 3 and the 5 and the y. Okay, so let's go ahead and do the 2's. 2 goes here 1, 2 goes here 1. And then for the x's, let's see what we can do here. This x goes here 1 and x goes there once. Okay, let's make sure there's nothing else to divide out. So you just have an x in the numerator, that's all that there is, and there are no x's in the denominator that we can divide it out with. So it's easy to conclude that we are done. This fraction, this rational, has been reduced completely. So we're just going to multiply across 1 times 1 times 1 times 1 times x times 1. Multiply them all together. That yields x in the numerator position. In the denominator, you just have 2 times 3. Oh, there's a y there, times y times y times y. 2 times 3 is 6. You have 4 y's multiplied by each other. That is y to the 4th power. Okay? So this, ladies and gentlemen, is how you divide rational expressions. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your study of rational expressions and the different operations on them, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions, comments, suggestions about the contents of this presentation, just place it in the comments section below and we'll be glad to respond. Don't forget to subscribe to our channel for updates to other tutorials such as this. We update videos to our YouTube page on a consistent basis. So if you want updates, notification of our uploads, do subscribe to our channel. More tutorials and worksheets can be found on math.serve.com, so you can go ahead and check it out. Thanks again for watching and have a wonderful day. Goodbye.